Hi grade 9s and welcome to your last lesson of the unit in linear functions. Last time we talked about parallel lines, and parallel lines never meet. And the reason why parallel lines never meet is because they have the same slope. In this lesson, we are going to be talking about lines that have different slopes. And what that means is somewhere along the line, pun intended, they are going to meet. They're going to intersect. So that's what we're going to be talking about in today's lesson. So before we do that, we have to talk just briefly about what it means to be a system of equations. A system of equations is two or more lines that are associated together. I'm just going to scroll down to our first example where we can see we have two lines and we have this curly brace here. So the curly brace is the thing that lets us know that we have a system of equations. So that's an indicator that we have a system of equations. The other thing we need to talk about is what it means to be a solution or to solve the system. Well, the solution to a system with two equations is simply the point of intersection of the two lines. So we're going to write this down. Point of intersection. That is our solution to a system. And in this lesson, we're going to be calling that a POI. Okay, so you're expected to know what a POI is when I use those letters. So POI stands for point of intersection. So let's get started. So we have two lines here, and we want to graph them both on the same axes. So if you recall in previous lessons, I'm going to call this line 1. The best way to graph a line, probably the easiest way, is to put it in the form y equals mx plus b form. So here I know that my slope is -2, -1 over 2. And my y-intercept is 0, -2. Okay, we can just make this explicit. I know this is this. All right, so after this example, I'll stop doing that. I'll assume that you know this. So we start at -2. We go across 2 and down 1. Let's do this again for equation number 2. So here we have a slope of 3, and we're going to write it over a ghosty 1, just to remind ourselves how to draw the slope. Okay, so we can pretty clearly see that our point of intersection is right there. Now, we're actually not done the question because we need to explicitly write down the answer. So I wouldn't get full marks just by drawing it. I have to say the POI is 2, -3. So this, in fact, here, this is my final answer, and it's what my teacher will be looking for. So let's do another example. All right, so what we'll notice right now is actually one of the drawbacks of using graphing to solve a system of equations. When I get really ugly coordinates, I have to be really careful when I go and plot these points. So I have to go up 2 and across 3. I have to be really, really careful. I have to hope that my human error isn't too bad. Okay, so you can see that actually one of the drawbacks of graphing is my lines have to be pretty perfect in order for me to see what the point of intersection is. So we've actually given you this example on purpose because we want to suggest that there is actually maybe a better way, or at least a different way, to solve a system. So we're going to solve this exact same system, but this time we're going to use algebra instead of graphing. So we call this method equating y values because really literally we are about to equate y values. So let me explain. We don't actually have to graph at all. What we're going to do is the first thing we have to do is we have to isolate y in both equations. And actually, we've already done it above, but we're going to do it again. Okay, so the key to this method is in step 2. In step 2, what we do is equate y. So what does that mean? Well, the governing principle or concept is this. We're just going to let y equal y. Very simply, we're going to equate y values. So what I need to do next is I need to substitute something in for y, but I'm going to do it in 2 different ways. So for this y, I'm going to substitute in this equation, and for this y, I'm going to substitute in this equation. And when I do that, I will be able to solve for x. And the way I do that is by clearing fractions. If you recall way back in a previous unit, what we do is we find the LCD, and in this case the LCD is 6, and then I'm going to multiply every term in my equation by 6 in order to clear my fractions. All right, so what I'll notice here is that this reduces to 3, this reduces to 2, and this reduces to 2. So let's take another line and just clean this all up. Okay, and now we can solve for x. So what we know is right now what we've done is we've solved for the x value of our point of intersection. Because the point xy, the point of intersection xy, is going to be a point that exists on this line and on this line. So what this solution is telling us is the x value of that point is 2. Now in order to find the y value of our point, what we need to do is sub x equals 2, okay, into either equation 1 or 2, because those are just rearrangements of the original 1 and 2 that we saw. Okay, so let's sub it into equation 1. Okay, so now we have found the y value of our POI. So remember, we still need to give a final answer here. The point of intersection is 2, 1. And of course, it should agree with what we got in our solution when we used graphing. So here you have it. You have the two different ways we can solve a system of equations. You are going to be required to know both ways, so graphing and algebraic. So what I would like you to do now is try the next two practice problems in this lesson, and you can stop the video, do the work, and then play it again to see if you got the right answer. Good luck, guys.